Okay, here is an example. Your task, I have opened the task manager, pressing a key, Control Alt and Del. Okay, you will see the first menu is there, that is processes. Okay, all the application, these are the application that I have opened in my system. Adobe Reader is open, Google Chrome is open, Microsoft Excel is there, Microsoft PowerPoint is there, Microsoft Word is open. Okay, Zoom meeting is open. These are the application that is open on my system. Okay, and all these processes is managed by operating system, and this is the main functionality of your operating system is it will manage. Okay, scheduler is there, process scheduler, the name given to the concept of managing a process is process scheduler. Process scheduler will schedule each and every process. Okay, here Adobe Reader is scheduled, Google Chrome is there. Okay, these are according to their alphabetic name. Okay, we can arrange them. Now you can see that there is a CPU, central processing utilization. How much CPU is utilizing? My system is utilizing it a 40%. Okay, memory is utilizing 77%. Disk is utilizing 0%. Network is utilizing by 0%, and graphical process unit is your 7%. Okay, these are the utilization percentage. Okay, CPU is managed by your operating system, memory management is managed by your operating system, disk management is done by your operating system, network management is also managed by your operating system. These are the functionalities, these are the process. Okay, then further there are background processes are there, and all these are managed by a scheduler. Okay, so here on your slide, wait a minute. Process scheduler maintain a record of the processes, add new processes when launched, remove all processes when completed. Okay, if I will close any application, means that process will be removed, and if I will click on any application, that process will be added in your process task. Okay, or a process scheduler will add them. Next is process table. Information about each process, including memory, that is RAM, priority, running or waiting. Okay, these are the information of each and every process. Their memory, which memory is given to which process, who has the highest priority. Okay, and which process is in waiting or in a running condition. All this will be shown in your process table. Okay, and this will look like this. This is your address of your process. Each and every process will be allocated an address or a memory, and they also have a priority. Okay, and their status is they are running, or it is in a waiting condition, or it is in a blocked condition. Okay, they are all managed by your operating system. And the example I have shown you that on your window task, there are different application and status is shown. All these application is in running condition. Okay, running condition. The status is given, or if it is in waiting, then here the status will be in a waiting condition. Viewing process with the Microsoft window. This is an example of your processes with the example of your Microsoft window. Okay. Then ending a process is also known as a killing the process. If we'll end any type of process, means we are killed that process or terminated or end that task. Okay. Next, in your processes, there is a dispatcher. Dispatcher. Okay. Dispatcher oversees the execution of each process by the CPU. Okay. Your dispatcher will oversees, it will check whether your process is in execution state, means in a running state, or it is in a ready state, or it is in a wait state. That all will be seen by your dispatcher. Okay. Each dispatcher gives each process a time slice of CPU time and change between processes. Swapping is done. Okay, time slice is there. I have shown you an example on a board. That time sharing concept is also there. In a time sharing, there is a time slice. Each and every process will allocated a time slice. Okay. Next is your multi-processing concept. Multi-processing, another computer system is the multiprocessor system having multiple processors. If there is a single processor, that is a uniprocessor. Okay, if they have a multiprocessors and the memory is shared between these multiple processors, okay, your multiple tasks or multiple process can be executed at a simultaneously time. Okay. With this configuration, they have greater computing power and higher reliability. If there are multiple processors, the example is there. Nowadays, we are using i3, i5, i7, and the processor is divided between different core. Okay, and different core are executing number of processes at a time. I have shown you an example. There are processes or your application that is multitasking. Adobe is open. Okay, Zoom is open. MS Word is open. Excel is open on my system. Means these are the different processes that is executing at a single time. And all this is done by a multiprocessing concept. Okay, if it is a uniprocess, then single process will be executed. Okay, if it is multiprocessing, we can also say that it is a multitasking concept also. Okay, then in the multiprocessing with the multiple CPUs, central processing unit are multiple, then multiprocessing is further divided into two types. Asymmetric multiprocessing is there and symmetric multiprocessing is there. Okay, your multiprocessing is further divided into two types, asymmetric and symmetric. What is asymmetric is tasks are assigned to a specific CPU. Specific CPU means there are number of CPUs. There can be 2, there can be 3. Okay, multiple, we are using a word multiple processing. So multiple CPUs are there. Tasks are assigned to specific CPU and each CPU had its own RAM. RAM is your memory. Here is a diagram. That asymmetric multiprocessing have a different CPU. There are number of CPUs are there, central processing, and they also have a different memory. Each task is assigned to its specific CPU. So application or a process is assigned to particular CPU. There is another application assigned to different CPU, and they have also a different memory. This is asymmetric. But in a symmetric, there are 2 CPUs or number of CPUs are there, but memory is shared. You will see here your memory, your RAM is shared, and that is in your symmetric multiprocessing. Okay, and there are number of application or your number of process are there, and each process will be assigned to any available CPU, and they also share a memory. Okay, so in symmetric multiprocessing, tasks are assigned to any available CPU. Which CPU will be available to them, the task will be allocated, and they are sharing a memory also. Okay, this is comes under your multiprocessing. Then further in the operating system, the functionality is there. Operating system as a resource manager, it will also manage your resources. Okay, what type of resources are there? Your printer, your keyboard, your mouse. Okay, these all come under your resources. Your file, your hard disk. Okay. Therefore, operating system in the resource management, that is, it can manage the resource of computer system internally. The resource are processor, memory, file, input output device. All these are the resources. Okay. In simple term, an operating system is the interface between the user and the machine. Okay. If we are using a mouse, we are using a keyboard or a Bluetooth keyboard or a Bluetooth mouse, all these resources are managed by your operating system. Okay. And here is a diagram. Your computer system is there, operating system is there. Okay. Then there are controller also. Controller are your USB slots. Okay. USB slot, Ethernet slot, your audio aux. Okay. Auxiliary cable slot. Okay. Your HDMI slot. These all having a input output controller. They will control your input output device, and all input output controller is also operated by your operating system. Okay. So input output controller is there, printer is attached with your input output controller, keyboard is attached by your input output controller. Okay. Here USB slots are all your input output controllers. Next, this is the structure of your operating system is, okay, first of all, you should have an operating system to interact with an hardware, and on your operating system, you can install your application. Okay. First of all, you should have an operating system on your system to interact with hardware. If there is an operating system, you can also install any type of application. Example is there, if we are having a mobile phone, but there is not any type of operating system is installed, then that hardware is not of any use. If we will install any operating system or Android on our mobile phone, then we can also install an application. Okay, without operating system, we cannot install any type of application. So this is a simple structure of your operating systems. Okay. Then definition is there. What is hardware? Hardware consists of CPU, central processing unit, main memory, input output device. Second is your operating system, and that is an example of your system software. Okay. Software includes process management, memory management routines, input output control routines, file management routines. All these are managed by your operating system. Okay. Then systems of programs. This layer consists of compiler, assembler, linker. These are also a system software. Okay. System program, we can also say that, or we can also say that system softwares. Compiler, assembler, linker, all these are the system software. Application program, this is a dependent on a user need. Okay, your application, I have to use an Adobe Scan or a CAM scanner. If there is an operating system, then we can install that applications. Okay. Example, your railway reservation system, your IRCTC app. Okay. That is an application program. Your bank database, your net banking. Okay. Google Pay. These all are the application programs. Then this is the main concept in your operating system. In an operating system, there are two elements. Okay, and these elements are your kernel and a system call. Okay, most important concept in operating system is your kernel and your system call. First of all, we will study what is kernel is. Okay, kernel is actually the heart of an operating system. Okay, kernel is in the heart of an operating system. Core part is of an operating system. Okay, kernel is also a core part of an operating system. It acts as an interface between the application and actual data processing is done at a hardware level. Who is an interface? That is a kernel between your application and between your actual data. In your operating system, there is a kernel. See this diagram on your screen. This is an operating system, your window. In your window or in your any type of operating system, there is a kernel. Okay, and kernel lies in the center of the operating system. which manage the communication between the user level application and the hardware installed on the system. If any type of request from your application to your hardware, who will take it? Kernel will take it from your application forward to the hardware. Okay. Kernel is the main component. Take the request from the application, forward to your hardware. Hardware fulfill that request, again kernel will back to the application. Means your message will be shown on your screen. Okay. So kernel is actually the heart of the operating system. It lies in the center of your operating system, which manage your communication. Okay. If there is any request from application, okay, kernel will forward that request to the hardware level. Okay. Next is your shell. Okay, I have told a name, that is system call, and that system call is generated by your shell. Okay, I will read it. A shell is simply a software that gives a user interface to various operating system functions and services. I will repeat it again. A shell is simply a software. It is a software. Only it is a software that gives a user interface to various operating system functions and services. The services that is executed by your operating system, shell will provide an interface to show or to execute that services on your screen. Okay, that is done by your shell. Shell provide a way for you to communicate with the operating system, and this communication is carried out either interactively or as a shell script. A shell script is a sequence of shell and operating system command that is stored in a file. Okay, shell is like a shield. Okay, it will execute all that services. Okay, and this shell will be communicate through a shell script, and these shell script are your commands. Actually, script is a language, okay, or a text, and that text are your commands. Okay, when we will write any command, shell will take that command up to the kernel. Kernel will execute that command through a hardware and show an output on your screen. Okay, next concept in your operating system is that is system call. Okay, the word is written here, system call. What are they? The interface between a process and an operating system. The interface between a process and an operating system. Now, interface between a process and operating system is provided by your system call. Okay, I will give you an example, then you will understand this. In general, a system calls are available as assembly language instructions, and system calls are usually made when a process in user mode requires access to a resources. Then it requests the kernel to provide a resource via a system call. So see this diagram, this one, where my cursor is. When user process mean when I will click a right click here. Okay, with my mouse, I will press a right click button. You will see this drop down list. Okay, when I click a right click button, this message, I have clicked a right click, this message will be created a call. Okay, when I clicked on a screen, a call is generated. Okay, and that call goes further to a kernel. Okay, then kernel execute that command, forward to the system call, and shows an output, and that output is a drop down list. In this manner, the system call is generated. I click the right click button, the function is called. Function is called, and that function that is called is known as system call. Okay, so I will repeat it again, the definition. The interface between a process and an operating system. I have clicked the right click from my mouse. Okay, the drop down is there. When I click the right click, a message is called. And what message? The user have clicked a right click button on a mouse, then that function forward to the kernel execute that function, okay, shown an output, and that output is your drop down list, and this function that is called is your system call. Okay, the interface between a process and an operating system is provided by a system call. In general, system call are available as an assembly language instruction. When I right click, the instruction get executed, and you will know that instruction are your source code, your code. Okay, that code get executed. System call are usually made when a process in a user mode require access to resources. Okay, I click the right click button. I require a resource. What type of resource? I want to open a drop down list on my screen, and that resource get open through a system call. That system call get forward to the kernel. Okay, so see on your screen, first this block is your user process. Okay, user process means I have the user, I have clicked through a mouse. Okay, then what is generated in the user process? System call is generated, and that calls get forward to whom? To a kernel. Okay, through an operating system. Call is generated, called forward to a kernel processor. Okay, kernel processor execute that system call. Who execute? Kernel executed that. Kernel executed that system call and return that system call or that output to a user. Okay, in this manner, your screen, your drop down list get shown on your screen. Okay, when we click on any icon, double click on an icon. Okay, when we click, function call is generated. Okay, means we want to open any application. That request goes to kernel. Kernel will execute that command and show that process or that output on your screen. That is your return system call. Output will be on your screen. Okay, this is the concept of your system call and your kernel. Okay, all these commands are written in your shell program. The word we are used, shell script. Okay, all these commands, your all that function that will execute on right click, this will be open, on double click, this will be open. Okay, that all are written in a shell script language. Next is your evolution of operating system, or we can say that a type of operating system. First is your batch operating system. Second is your multi-programming. Third is your time sharing, also known as multitasking. And fourth is your real-time operating system. And last one is your distributed operating system. Okay. First one, what is batches? This is the diagram. Means there are number of jobs. Okay. Each and every user have its own job. That job is get operated by an operator and put in a particular batch. These similar jobs are placed in a particular batch, and then batch will be executed through your system, through your operating system. Okay, this is the concept of your batch operating system. In a batch processing system, in a batch processing, same type of job batch, together and execute at a time. Means a batch is a set of jobs with a similar name. The jobs that are similar, they are put in a single batch and get executed. This is a name describes batch processing operating system. The operating system was simple. Its major task was to transfer control from one job to the next job. Okay. If one completed, then next will be executed. Next will be executed, then another will be there. Okay. The job was submitted to the computer operator in the form of punch card. Okay. Job is in the form of a punch card. The card is there, and on that card, the punches are made. Okay. I will show the image how it's look like. Okay, these punches are made on your punch card. This is the actual code is there. Okay, and it look like this. This card is there. Okay, and they have a hole, and this will mention some code. And this tape will be placed in your tape driver, and your batch processing system is look like this. This tape will be placed in your system. Okay, this is actually, this tape is your batch. Okay, and this batch will be in your tape driver. Okay, there is a, this punch card will be put in your tape driver, and that tape driver will be get executed. If one batch get executed, second batch will be placed in your system. Second will be executed, then next one. Okay, this is your punch card is. The system have a tape driver. You will place this punch card inside a tape driver. It will execute one by one all the jobs. Okay. The job was submitted to the computer operator in the form of punch card. At the some later time, the output appeared. The OS was always resident in a memory. Okay, the operating system was always resident in a memory. The common input device were card reader and a tape driver. All these punch card is read by your card reader and a tape drives, and all this process will be executed according to a batch. Common output devices were your line printer, tape driver, and card punches output devices, and input device is your punch card. User did not interact directly with the computer system, but he prepared a job. Okay, user cannot interact with the computer system, but only he can prepare a job in the form of punch card and put that punch card in a card reader, and your system will execute that punch card one by one. All the jobs get executed. Example is program were loaded into a memory manually using switches, punch cards, or a paper tape. Okay, your paper tape also use, your punch card also used to execute your programs. Okay, this is your batch processing look like. Next is your multiprogramming. Multiprogramming is a technique to execute number of programs simultaneously by a single processor. There are multiprogramming, but processor is single. Okay, in a multiprogramming, number of processes reside in the main memory at a time. The operating system pick and begin to execute one of the jobs in the main memory. Okay, here it is a diagram. There are number of jobs. Okay, processor is single. One by one job is picked and executed by your operating system. If any job it is in halt condition or in a waiting condition, then next job will be picked. Okay, then that will be executed. Another one will be executed. Okay, so advantage is there. Efficient memory utilization should be there. Throughput increases. CPU is never idle. Okay, these are the advantage of your multi-programming. But in your batch operating system, batch processing operating system, CPU will be idle. Okay, because a single batch will be executing, when that batch will get completed, then next will be executed. While the time being that batch is executing, the CPU will be in an idle stage. So that is the limitation in your batch processing. Your CPU will be in an idle condition. So here in multiprogramming, your CPU will be never in idle. So performance increases. Efficient memory utilization is there. Throughput increases. Maximum CPU utilization. Next is your time sharing system. Time sharing or a multitasking is a logical extension of multiprogramming. Okay, time sharing or a multitasking is a logical extension. I have shown you a message that screen on my system. I am using a Android Adobe Reader also, MS Office also. I can also listening a music. I am also attending a Zoom meet. Okay, this concept is called multitasking. There are multiple tasks is done on my system. Okay, and also name as time sharing. Multiple jobs are executed by switching the CPU between them. Okay, so what is multiple time sharing is there? Multiple jobs can be executed. Okay, when you will see on your mobile phones, you have opened a number of applications. Okay, you can switch from WhatsApp to your music player, to music player to your Facebook, to Facebook to your Instagram. That is your concept of multitasking, and you are sharing the times between this application, and all this done by a time sharing operating system. In this, the CPU time is shared by different processes. Sorry. So it is called a time sharing system. Time slice word is used. Time slice is defined by the operating system for sharing CPU time between the processes. And your time sharing system operating system is a Unix operating system. Nowadays, all the operating system that is in market that we are using that are time sharing system. Okay, here is a diagram of your process state. Okay, the process can be in a ready state, can be in a running state, or can be in a block state. Okay, if the new job is there, new process is there, first of all, it should be in a ready state. Okay, means this process needs a processor. If a processor is allocated to a particular process, means that process is in a running state. If that process is terminated, means through any condition, if there is if it is completed, then it is terminated. If it is in interrupt or in any fault condition, then it placed in a blocked state. Okay, these are the states of your process. Your process will be placed according to time slice. First of all, that process will be in a ready, then allocate a processor in a running state. Then after that, if it is its time slice gets over, placed in a blocked state. Okay, next process come to a running state, again in a block state. Next process come in a running state, block state. If it is completed, get terminated. Okay, in this manner your time slice will be provided, and each and every process get executed according to time sharing concept. Next is your real-time operating system. A real-time operating system is a multitasking operating system intent for application with the fixed deadline. Okay, deadline is their fixed deadline. Such application includes some small embedded system, automobile engine controller, industrial robot, spacecraft, industrial control, some large scale computing system. Okay, so example is there of real-time operating system is an American airline. Okay, airline reservation system, IRCTC, Indian Railway Reservation, online banking, Google Map, these all are using a real-time operating system. Okay, so real-time are further divided into two types, hard real-time and soft real-time. I have told you that real-time means there is a deadline. If your process not executed at its time, then that process will be count as a fault failure process. Okay, so in a hard real time, software system has a set of strict deadline. Strict deadline is there, and missing a deadline is considered as system failure. If that process have to execute in a 10 millisecond, if it is not executed in a 10 millisecond, then that process is, or that system is a failure system. Okay, because it is not completed at a particular deadline. Next is soft real-time system. Soft real-time system try to reach a deadline but do not fail. Okay, any type of process that want to execute in a real time or in a deadline but it cannot execute, it will take few seconds but not in it in a failure state. Okay, that time of operating system is called soft real time. Like example is your multimedia system, digital audio system, that is your come under your real soft real time system. There is a deadline, but if it is not completed in a deadline condition, that process is not in a failure stage. Means soft condition is there. Hard real time is if it is not completed, that system or that process is in a failure condition. And last is your distributed system. A distributed computer system use multiple CPU to execute multiple processes. There are multiple CPU. Each CPU have a different memory. And if there are different processor, means CPUs are there, then each and every CPU can execute a particular process. Multiprocessor communicate with each other through a multiple communication line. Okay, so diagram is here. There are multiple CPU and each CPU have its own memory and disk, CPU memory, CPU memory, CPU memory, CPU memory. Okay, and each processor can execute an individual process. Okay, so if there are 5 processes, they can execute at a particular time, at a simultaneously manner. Okay, if there are 10 processes, they will be allocated to each and every CPU. So time speed is, executing time is less in your distributed operating system. So CPU utilization is maximum, memory utilization is maximum, and process execution speed is also maximum in your distributed operating system. That's all for your today's lecture. Okay. Now I will launch the poll. If you have any question, you can message me. First question on your screen. Nishant, virus is also a software. It is a program. Any type of virus is a program. Okay, virus stand for vital information resource uninterrupted services. Okay, it is an information, vital information. So what type of information? Vital. And which form? In the form of code, source code. Okay, the program will be sent or will be placed in any type of your application. When you will install that application, that program will execute. So that program is a code. If there is a code, means that is a software. Okay. Next question on your screen. I will end this post. Second question on your screen. Which of the following option is not the function of operating system?